In this lecture, as I said, this is the first lecture on time series econometrics. So we started with, you still can relate it to what we covered last week about autocorrelation, because it's very related to time series anyway. But what we will cover today is dynamic models, when we talk about introducing lags. So we'll cover auto-regressive models, distributed lag models, and ARDL or auto-regressive distributed lag models, and then we'll explain what we mean by stationarity and how to test for that. So if you cover these 2 points, that'd be great, and hopefully by the end of this lecture you will as I said, we start with autoregressive models, and what that means, if we have AR process, meaning that your variable, remember we have time series data, we talk about time series data now. So you have your dependent variable, y, in time t, depends on itself in time t minus 1. So if you talk about growth rate, let's say this quarter, depends on the growth rate in the previous quarter and in the previous quarter, and then you can go back in time p times or p lags, okay? And of course plus some error term, okay? So when we talk about autoregressive process or AR process, usually ARP, p here is the number of the lags, how many lags or how many time periods you go back in time. In this example, you could go to P. This is example about the US GDP AR2 model, meaning that the growth rate this quarter, if this is quarterly data, depends on the growth rate in the previous quarter and the growth rate in 2 quarters back, okay? Plus some error term, okay? And this is the estimation of the model. So we have data for this, for growth rate, the US GDP growth. And when we estimated this model, this is AR model, you see autoregressive model. So auto, it regress, you regress the variable on itself in the past. So GT regressed on GT minus 1 and GT minus 2. So it's the same variable, but in the past. So in this case, when we used Okan dataset, you have access to the dataset now in R, so you can replicate exactly the same results. And I'll post a video to show you how to replicate, how to reproduce the same table exactly. So what we have here, we have an intercept. This is delta, the estimation for delta. This is the coefficient, and this one is the first lag, and this one is the second lag. Okay, so this is the first lag, GT minus 1, and this is the coefficient for the second lag, GT minus 2. And it seems that both are statistically significant, since that we have small p-value. It's smaller than 1% in this case, and smaller than 5% in the other case. So that means it could be important to include or to consider, when you talk about time series, to consider the lags. Remember, one of the ways that you could get rid of or correct for autocorrelation is to include lags, because this information, if it is not included explicitly in the model, where the effect of these lags will go to? Yes, the error. And if it goes in the errors, that makes the error serially correlated. Okay, so taking this back here, taking them away or out of the error, putting them explicitly in the model, that means that it's not longer so serially correlated. Okay, so that can help with autocorrelation issue as well. Okay, so introducing lags could be one of the important issues with dealing with autocorrelation with time series data. And it makes sense, because if you think about it, if you have high unemployment rate in the previous quarter, so it's likely that you're going to have high employment rate this quarter as well. Or if you have high growth rate the previous quarter, so the chances that you will have a high growth rate again might be very high. So this sort of trend that you see in the data and in time series data. So sometimes you see upward trend or downward trend. I know sometimes the series go up and down, but in two consecutive periods, so the chances they actually follow the same trend are much more. But in that case, okay, so in our case here, it seems to be important to consider the first lag and the second lag, because both are statistically significant when explaining GDP growth in time t on this quarter. So how many lags to go back in time? Because in this example, okay, in this example, we consider only 2 lags. Why should we go back only 2 lags? Why not 4 lags? Why not 3 lags? Why not 10 lags? Why not 12 lags? So why should we go only 2 lags? So there must be a reason for how many lags to include in the model. And this could be either, mainly most people rely on some information criteria. So they just use one of these criteria. The archaic information criteria. So these are different lags. So this is the same model, but with different lags. So with only 1 lag, 2 lags, 3 lags, up to 5 lags. And then you choose the number of lags that will minimize, will have the minimum for these, minimum value for these criteria. Okay? So according to this one, to the first criteria, so 4 lags should be included because this is the smallest number. According to this, might not be the same. It's actually, it's the second, yeah, so it's 2 lags. Okay? So sometimes people come to me and say, well, actually there are more information criteria, not just these 2. So you can, if you do this in eViews, it produces like 5, 6 table full of criteria, and sometimes you have conflicting results. So you need to your own judgment in this case. And I personally would do, I will use the number of lags that will eliminate serial correlation, autocorrelation. So after I estimate the model, let's say I think it's 2 lags, and then I estimate the model, and then I test for serial autocorrelation. If I have serial autocorrelation, that means I need to include more lags. Okay? If I find no serial correlation, it might not still make sense to me, because I'll tell you why. If this is quarterly data, and I see like only 2 lags were enough to eliminate serial correlation, I still worry about seasonal effect. So what if this data was, let's say, if there's some seasonal effect, means that I need to go back 4 quarters, not just 2 quarters. So sometimes I even go beyond what these criteria suggest if I feel like, okay, there's a reason to do that. Okay? And of course, you need your own judgment about the results you obtain as well. Does it really make more sense to go back more lags or not? But let's say, okay, the first step is to check these information criteria, and then you choose the number of lags that give you the minimum value for these criteria. Some people would look at the choreogram of the residual from the estimated model and see whether these bars go above these. So in that case, you remember from last time, each one of these represent one of the lags, okay? And in that case, seems we really need to go back in time so many lags, because one of them is just going outside these borders, okay? So as I said, sometimes it is down to your own judgment, but you still need to think about what the criteria suggest. What if all these criteria suggest only the same lag length? So it must be some reason in the data that actually show this. But anyway, if I have, let's say, monthly data, and you say I'm using, I estimated the model, and I include only 1 lag, I'll be surprised if there's no serial correlation. Okay, so it depends on really the frequency of your data as well is important. Okay, so quarterly data. If you have annually data, and you included one lag, I would understand. It might, okay, there might be no reason, like no reason to go back more than 1 year, okay? Because maybe if there's any seasonal effect or anything that, okay, will be backed up from last year. So it might be some, I might understand that. But if you have monthly data and you said, oh, I estimated a model with one lag. So are you sure this is the, so you need to check your specification. And let's think about one rule of thumb here is check your serial correlation. Do you have serial correlation or not? Think about the any seasonal effect, and that will depend on, again, on the frequency of your data. Do you have annual data or semi-annual or quarterly data or monthly data? Then you need to think within the context of your data as well and see how many lags to include. So let's say that we're happy with R2, AR2 with 2 lags. What we could do with this model, we could do forecast. So we could do the same stuff that we do with regression. So we can use the estimated coefficient to forecast. These are point forecasts, and these are the confidence intervals, the upper and lower bands. And in that case, you could find or forecast future values for GT plus I. T here is the number of observations or the number of years. So you can go out of sample. So if your data end in 2000, then you can maybe forecast for 2001, okay, for the next period, etc. And that's what we call the out of sample forecast. And we will probably have a full lecture on economic forecast, and we'll show different methods how to do it. But for now, we still can do it the same way as we did with the basic regression when we estimated a model for household income and how household income, the effect of household income on consumption expenditure. And then we said, okay, since we estimated the model, now we can use these coefficients to estimate how much household would spend on consumption, given that we know their at certain level of income. So we can actually make some sort of prediction or forecast how much they would spend on food. And this is the same, exactly the same way you could, if you know X, then you can actually make forecast about that. And your X's here are the lagged values. So this is just plotting the 3 points that we forecast with the bands, with the intervals, confidence intervals. So these blue dots here are the future values that are forecast using the same model. So this is the ARDL model. Sorry, this is the AR model. So the autoregressive model. So what do you mean by autoregression or autoregressive model? So YT, or the variable, is regressed on itself in the past. So how many lags to go back? So that depends on the information criteria, the serial correlation, whether you get rid of the serial correlation or not, and then the frequency of your data, and whether or not you worry about the seasonal effect from past year. Okay, so these are things you need to think about. Okay,